Uh, I think that I can start. Hello, everybody. My name is Arsenij, and I'm going to be here until the end of the day. I'm going to help the mic move around properly. And now Andrey Borodin from Yandex is going to present with the story of the connection pooler Odyssey. Yes, as has been said, I am in Yandex. I work with Postgres. And for the year and a little more now, this is a critical item in front of any query. Now, in Russian, we say Odyssey, and everybody in English says Odyssey. And now Odyssey is not Odyssey. Now, Odyssey is the journey and what happened to him along the way. So the Odyssey in ours, and I just say it Odyssey like I used to. Connection pooler. Now, I don't like all of these English terms, and I'm pretty sure that we can use our language to find the terms for anything, but for a connection pooler, we don't have a suitable word. We could call him manager, but manager is not exactly what we're looking for here. So in case you know how to say connection pooler correctly in technical Russian, please tell me. Connection pooler is a very simple application. All it does is control the client's connections. Now I'm going to speak a bit about Postgres in Yandex now. We know that Yandex Mail has moved to Postgres a while back, which has 1 million plus something queries per second that are carried out by Postgres, where you have like some gazillions of lines, and we have hundreds of millions hundreds of millions users writing into Yandex email. And now we have Yandex Cloud, where we have a couple of petabytes of queries, and now the amount of requests per second are larger than 1 million requests per second. So in Yandex Cloud, we also have different services migrating to it, which would like to get a controlled Postgres, and along with it, they get the Odyssey as well. Now, why do we need to control the connections with the base? Well, clearly for there to be a lower number of connections. Now, the connections together with the postmaster of Postgres should be as few as possible, because one connection is one backend, is one process that has been forked by the postmaster, and it is on this process that we see various caches hang that are optimally to be maintained and to not be doubled up. Now, other than that, there's a lot of algorithms that help us to work with consistent snapshots in Postgres. Now, the backends they just cycle through backends with a cycle, and this is a very typical function for getting a snapshot. For each connection, we get some sort of a code, and at the same time, it is necessary to go through all the connections that are present in the so-called block RAM. Now, where can we save on the server connections? And now, the simplest and the most understandable way for the service that you've just created is application side pooling. And the more complex item is a proxy puller, and I hope that sometimes we'll get an inbuilt puller into the database. And frequently we see the combination of everything that's available being used. And now application side pooling is a simple yet reliable solution that when you have an application that works with a database, but the amount of connections starts to grow if your application is already under the power load balancer, and if you run a bunch of instances of the application, each one of them supporting a separate path. And at a certain period in time, you understand that your service is already bringing in a lot of money, and you would like for it to be fail-proof or fail-resistant, and you start to distribute your server according to the areas of availability, and each one you have the balancer of load, each one of them has a bunch of backends, and each one has a pool of connections. And after this, your database starts to go above and go over one instance of Postgres. You understand that you need sharding, and then you now have areas of availability which have the services of load, the house that Jack built, or as mathematicians call it, the combinatoric explosion. And at one point, there are too many connections with the server for the side pooling, and there are a number of things you can do. For example, you can use the pooler that is between the database and your application. Right now, the choice of this is fairly large. You can use PGPool2, for example. It is an application that knows how to do many things. It knows how to, for example, decipher the reading and the writing queries. It tries to understand what your queries are, but because it is doing many things, it has problems. And in particular, it only knows how to do session pooling. There's also Crunch Proxy, which is an interesting attempt of the company Crunch Data to create its own proxy pooler. It is written on COOL, but the project is not being heavily developed right now. And then there is a simple PG bouncer. It's clear, it's understandable. It's a connection pooler that is designed for transaction pooling, and it tries to not do anything else. It's a utility that does one job, and which is why it does it well. And in the majority of cases, for our loads, in one way or another, PG bouncer can be applied, but it has problems. And the first thing that you encounter is that the fact that PG Bouncer has a fairly complex system of diagnostics, PG Bouncer just does not tell you why it was unable to open the server connection. So you don't have any error code. Either your password was wrong, or you had too many connections, something is wrong with the database, and you always get the same mistake that does not tell your mistake which way should it degrade to, or should you start throttling the queries, or should you start monitoring and call in the person who's going to start fixing everything. So the diagnostics with the bouncer is a fairly complex endeavor, but with secondary and tertiary signs, you can tell what you can do to get your service up and running, but Bouncer doesn't help you with this. Now, the other problem, which is more fundamental, diagnostics can be fixed, but the PG Bouncer is programmed and designed to be a single flow, and it's made very simply, and in this simplicity, the scalability is just absent as a phenomenon. And here on top, you can see where you have 90% load, and the database is not super busy, but the Bouncer is not quick enough at passing the bytes here and there. In principle, this is a solvable problem. Before, we just had to apply a little patch that would allow the bouncer to separate the ports with a different bouncer. And right now, it's a technology that is currently supported in the upstream bouncer. You don't even need to patch it. You just need to make sure you set up the reuse port. But the problems still occur. And here you see the HTOPs with the cascade of bouncers, where you have an internal bouncer that still gets limited by one core. In Cascade you can do without a single bouncer, but then you have a connection pool, and each one of the bouncers collect. And so we come back to the same problem. There are too many connections. And if there is some bouncer that terminates lots of connections before the database, then the scalability of the bouncer is still an issue. The external layer of bouncers is usually used in order to get the incoming TLS connections. TLS connection is an operation that requires the participation of the central processor much more than just the typical displacement of bytes from one socket to another. So for the central processor, the data flow that are measured in bytes per second are just unnoticeable, but the necessity to carry out cryptographics, so when you're doing DLS and shake, it is fairly substantial. Therefore, the cascade of bouncers is able to cope with the issue of performance of the TLS connections, but is a lot harder to service, and it cannot manage the scalability, the scaling of data transfers, so the stability of connections, which causes issues. And last but not least, what is basically was the trigger for the development of the Odyssey, well, one of the main triggers, is the fact that Bouncer imitates the behavior of the database in terms of lost connection. So if your application, for one reason or another, has dropped the connection with the database, then the bouncer will continue to carry out the same request as it was the same query as was carrying out. And we have directed their attention to this a number of times. We have wrote them a pull request, we have submitted it, and they're still reviewing it right now. And this is one more problem: that bouncer did not have a very good technical support. One of the things that I think that is a great benefit of Odyssey, straight away after Odyssey came out, they started developing the bouncer much better. But yeah, I'm getting ahead of myself. Because of all of these issues, we came to a necessity to develop our own connection puller, which we called Odyssey. And Odyssey is based on two libraries, and I am going to speak in more detail about its architecture. One library is called Kiwi, and the second one is called Machinarium. And the Kiwi library is processing the standard Postgres protocol. The standard process of message exchange was called a prototype. For each of the messages in Kiwi, you have a functionality written down that allows it to just simply be formatted and to be sent in a unanimous fashion, be that you are a client or a server. So you could use the code from LimbQ or from the back end of Postgres. You can always it always can understand where exactly it is. But in the case of the connection puller, it is both at the front and the back end of Postgres at the same time, of the Postgres protocol at the same time. Machinarium is a more complex library which is designed for multi-flow calculations and for processing of messages regarding events. In Machinarium, you have the so-called machines. And the machines, in essence, is just a jet that is attached to a certain processing core. And on it, you can see the machines registered. You can have the coroutines registered. Coroutine is a program that gates the control, the time slice of the central processor of the operating system, and it continues running until it doesn't get into a state where it has to simultaneously or asynchronously wait. Here we can see three flows. One is created by Machinarium, one creates the Machinarium, the second one creates the Machinarium, the middle one the second one is already what is happening inside the machine, which is the coroutine, which in turn creates the next coroutine, and the top coroutine causes sleep. This is the most simple asynchronous standby time, wait time, which is in essence when the CSV worker tells the Machinarium that it wants to give the current time of the central processing unit to some other coroutine, and to come back in 0.0 milliseconds, whatever. But in the same manner, the machinery, or the worker, the coroutine can ask the Machinarium to wait for the event on the socket for a certain amount of time and to come back either after this time passes or when the data appears on the socket. In essence, when it comes down to it, it's just an analog of the library on which Gbouncer is based. In PGBouncer, it's lib event, and in Machinarium, it's a scalable version of a lib event, which is designed for connection pulling or for working with data movement. And the architecture of Odyssey looks like this. We have the main machine, so the main flow, where you have one coroutine which services the socket, which looks at the availability of connections in a backlog, and if you have the incoming TCP connections, then it passes to one of the workers. It creates in one of the workers a new machine that then is passed the connection, and no fork happens. You just have one message passed down the channel, a message regarding the fact that you need to launch a new coroutine that is going to be servicing the work of one connection. Thanks to this coroutine approach, when we give the control not through return but through the summoning of the function of read data or sleep, the work of one machine on servicing one client service is not described by the state of the service, but by the following call. So you have to wait for the startup package to come, then you have to wait for the authentication to come, then you have to wait for the first byte of the first request, and then you have to ask for the server connection, then you have to pass it to the server connection. So this is a step-by-step program which is much easier to be perceived than the Olympic U machine state inside. When you have a processor in which you write down the conditions, and if the last time I was exiting, if I was in a state of exiting, I check the exit. If I was in a state of connecting to the server, I check if the server is available. Apart from the main flow, we also have the flows that are responsible for the pull and the maintenance in a consistent state of the half server and server and client connections, and which would also be responsible for the state of the console, or what is in PGBouncer called the database of the PGBouncer. So it's a service database where you can use the show stats, show clients, show calls, and other commands as well. Right now, we use Odyssey in production for many thousands of instances of Postgres, but the process of its implementation, in the process of implementation, we went through an enormous amount of mistakes. This entire scenario and narrative has shown us that the code of the bouncer, despite it not being developed very well, is being developed with great attentiveness, and the developer of the bouncer have encountered an enormous amount of issues. And the first problems that were a pretty long way away from the current problems, we have implemented Odyssey in the first production systems, and everything worked fine until our friends from Postgres Professional have gathered together and started benchmarking Odyssey and saying that in our production we have a system working with memory leaks. Well, we didn't have an official release back then, but they told us and we fixed it. But it just gets more interesting from here on out. Both on the entry and on the exit to Odyssey, we have the TLS encryption, and this TLS encryption requires certificates. These certificates can change, and Odyssey, in order for the certificate to be replaceable, was rereading this certificate. A great scalable connection puller addresses the file system, which becomes suddenly unscalable, because with a certain amount of incoming TLS connections, everything that the connection puller does is just rereads a lot of TLS certificates. It is the problem that led to very difficult servicing, a very difficult streamlining, because we had to reboot the entire thing.
In order to solve this problem, well, we solved this problem, but another problem emerged when 20 or 30,000 incoming TLS connections is coming. The puller will accept all the connections, and then it will start TLS with each one of them. If timeout is, for example, 3 seconds, and you simultaneously perform 3,000 operations, with high probability, none of them will be successful. And this is why we had to implement the stoppage of acceptance and inversion of the priorities. So when we understand, then now we can start to connect somebody else. We take the last one, because the possibility is the lowest to stop during the handshake due to timeout. Another problem which we encountered recently is that it was added to Postgres GSS API encryption. Now Postgres is waiting, either during the connection or during the startup package, or with package of TLS connection or GSS API SQL will send the request to GSS API. And PGBouncer, at the moment of release of 12 Postgres, we're not supporting it, and they didn't know what to do, and they just interrupted the connection. Now it has been solved, fixed, and the client will request for TLS connection only when puller says so. So using Odyssey, it can be done logical or physical replication. In the version 1.0, we had certain storages where we said, for example, that this storage is for physical or logical replication. But we encountered certain problems, and Evgeny suggested to use more efficient way to configure the replication when there is no configuration for replication, but when the client comes and requests to connect not to backend but to well sender. We ask the database, and the database tells that the base backup is impossible, or it says yes, we open the well sender and replication of a certain database. Basically, this is a break and change, and in the version 1.1, which will be released soon, these two configuration methods will not be necessary. It will be enough to delete the row in the config, and then it will work as it was before. Management of the number of servers is the main task for connection puller. Connection puller must establish as less server connection as possible. But in config we have a limitation. User config says that for a certain database and certain combination we can open, for example, 1000 connections maximum. And Odyssey's behavior was quite logical. If we have 1000 incoming client connections, we open 1000 server connections. But in fact, this is not the best idea. And in PGBouncer code, we found a long comment that the opening of server connection is much more costly than execution of LDP requests. And during a lot of connections in pooling, we should not open all of them at once. And this problem was identified in the services with certain peak loads, which could trigger necessity to open a lot of server connections. Now we have a configuration where we open not more than 4 connections. And this is much faster than PGBouncer, but we will not open all the connections up to the limit. Actually, the management of server connection is ML task. The graphs of the bouncer and Odyssey, they're normal graphs. They can go up and down, but this is actually wrong. Good puller should forecast how many connections it will need. It shall have a certain strategy and to maintain this strategy. But we don't have a good solution to forecast the future. But when we will come up with a solution, then right away we will implement it. Or maybe if you have an understanding how we can forecast the load in the future, please tell me. Management of client connections is in a way a problem as well, because we've been using the high-load databases with tens of thousands of incoming connections, and they were fixed at some point. But when we started to deploy on small databases on half of the process core, we encountered another problem. What happens to the services which come to connection puller takes half of the package and then they're silent. They don't have enough time for Python to say something else. And that was completely unexpected, because they can be actually all of them can be like that. And we went to PGBouncer code, a long comment. We found that slow clients is the same problem as too fast clients. And if the client is silent in identification mode and it is silent for 15 seconds, then PGBouncer just bounced it away. It was not available in version 1.0, so maybe it will become available in the future releases. Max routing client is in charge of the maximum quantity of TLS handshakes in order to invert the priorities during the incoming load of the TLS connections. Configuration and monitoring. We tried to do this as simple as possible, and Odyssey can listen to several ports at once with different configurations, with different TLS connections, and we have a block of configuration which is called listen. If you read the config from the beginning to the end, you will understand how it works. So basically, listen says which port on which interface is open and how to listen to it. Configuration area called storage, it's a description of the way to connect with the database, which physically exists. It's either remote or local. Local means the administration console, which means PG bouncer. And the last thing which you need to configure is the database user. Here we write the size of the pool, what time should elapse when we should connect the user if it cannot find the server, and when we should skip the errors, and one of the configurations of Postgres is client forward error, where we have to imitate the bouncer's behavior, and we send the same error as the bouncer. And if by default it says yes, then we will send the same error which Postgres has been trying to say. This configuration tells us that if client connection is lost, then should we roll back the transaction which was in progress? Or should we send cancel to the request which is being executed? And this is the same configuration of bouncer, which says that we should add the ID address of application name of the server connection. And the last configuration is QuantiLive for transactions and for queries to enhance the monitoring. Why do we need Quantily queries? Bouncer gives you back the average time of transaction and average time of query. But average time doesn't give you any understanding of what's going on. If you have 10% of very slow queries and other queries are immediate, then on average you will see that the database is working somehow, but actually 10% of the users will suffer. So average time doesn't characterize anything. And 0.99 quantile of the response will tell us that 99 responses is within 1 millisecond. And it shows quite well that your database is completely failed, or just there is a minor interface problem, or maybe disk subsystem problem, or maybe some other process. And quantile of time of query helps to diagnose the system better. But you need to show it on a graph, because the immediate value is not good enough. Monitoring is quite standard in Odyssey. We inherited it mostly from Bouncer. Utilization is the time, processor time of performance of machines of the workers from the Odyssey. If 4 workers are highlighted, it means that Odyssey can work on 4 CPUs, and you will see utilization of 400%, which means that you need more workers. Saturation error in our case is the same, because both of them analyze the log of Odyssey, which needs to calculate the number of connections which were unable to get the server connections, the number of TLS error, which will tell you about the overload of the central CPU timing, and also other errors which are not in line with the standard pattern. Odyssey doesn't have a technology for online restart. Bouncer has a possibility to install a new version and to tell Bouncer to start the new process and to take the old descriptors from the old processor of Bouncer. But for us, this probably created more problems because all of a sudden it stopped working, and this is why in Odyssey it was not realized. Actually, even reload of Odyssey process causes certain problems because you change the server connections configuration, and then it starts to create new connections. And reload is not much more efficient than the simple restart of the service, but it will be reflected on the performance graphs. Another important thing about Odyssey monitoring is that you have to check the availability of all the ports, because if you are listening to several interfaces and due to some reason after change of Bouncer to Odyssey, the Bouncer didn't close the port in time, Odyssey will start on the IPv6 interface. It will be happy to open the port. It will try to start on the IPv4 interface, and then it will see that the port is busy. And then it will migrate to another port, and after that all the clients who came under IPv4 will see that the database has failed and nothing is working. Odyssey we're trying to develop as an open source product, and many people come to us and suggest their features, and for us it's very important because when we supported in Bouncer the Surya ports, we need something to highlight on that background. So if you have any problems with Odyssey, please tell me and we will think what can be done. For example, the external contributors brought scram-mode authentication, and we're in process of merge with Bouncer Resume, which we need during the upgrade of the database. For example, you can pause all the clients. They think that the database is slow, and at the time you upgrade the database, put it back, and the client just thought that something was slow, and then they see that it's upgraded to Postgres 11 or 12. So this is the end of my presentation. If you have any questions, please, you're welcome. Hello, I'm Alexey from Ozon. The question is when HBA authentication will become available for Odyssey. Because on GitHub I asked this question, but nobody understood what I meant. Let's discuss this separately because I do not remember, to be honest. The thing is that currently you cannot limit the client by IP, by host name. You can connect from anywhere, if I understood correctly. You can limit it with IP tables. No, IP tables is great, but not the best solution because Odyssey is an analog of Bouncer. And I think HBA authentication should be very suitable. Okay, let's discuss it further. Let's create in GitHub. It's already available. Actually, I can show you. Okay, let's discuss how it can be done. Thank you. Thank you for your presentation. Another idea I would suggest to add metrics endpoint so we can take statistics with Prometheus. Yes, we actually met with some people from Prometheus. They suggested to link with their library, which I'm a bit afraid of, because we have two solutions. Either I create their library myself, which is also frightening, but of course, to parse the logs, it's not what we would like to do. I have a question to Alexei. We need only Prometheus, or there are other systems which we need to support? Let's look at everyone. I think that Prometheus is more or less industrial standard in terms of monitoring, but maybe some people will disagree with me. But this endpoint metrics is quite convenient, and we can use it not just with Prometheus. I think this is an interface to provide the metrics outside. And I would like also to ask about other metric systems, for example, Zambix. I thought there is something else. Well, anyway, this is a very convenient interface. You don't have to parse the logs. You can just go to that endpoint and check. So we will need to create a server inside Odyssey. Well, it's just something which you can do to distinguish yourself from Bouncer. This sounds like a plan, yes. Okay, blockchain is interesting, but no, not right now. Thank you for your question. I have also a question. I will stand up. Are there any plans to add audit to audit? Yes, we had an idea to add extensions to Odyssey so we can write some module which would be uploaded with hooks which can hook. But if we add extensions, then the question will be, we will extend it with what? Somebody will write hooks for audit? I don't know. In this question about audit, there are two parts. The first part is support of theoretical support. Yes, I agree, it should be done. And actual support. I'm not a specialist in audit of the requests, and if somebody is interested to write a module to analyze the queries, which can be used for queries, then please do so, and we can discuss which hooks are necessary, and then it can be done. Thanks for your question. It's an interesting idea. It's me again. If we go back to the beginning of your presentation, you said that you don't like connection core. I have a good alternative. When I studied in my university, we had a multiplexer of connections. Yes, it's an exotic word. When you say multiplexer of connections, if we had only one server connection, then yes, but no, but actually we multiplex the number of client connections to a certain number of server connections. If the client was connected only to one server, actually multiplexer means more than we want from it. I think it will be worse than using the foreign word. Let's vote. Who likes pooler, who likes multiplexer? I think as a community we can decide which terminology will be used. Who is for multiplexer? Please raise your hand. Just two people for multiplexer. Who votes for pooler? I think much more. But it was a nice try. No, actually I'm using both. It's just an idea. Yes, we should select the ideas, and maybe we will convince everyone that now we have PG multiplexer. Thank you for your presentation. I have just something to add, not about Prometheus, because it would be vendor log, but different clients has different wishes for API to collect the metrics and the data, and then the community will be able to write the additional libraries for Prometheus, for AdWatch. But what should we do in Odyssey for this? You can make a suggestion. For example, you have a protocol for collection of metrics, and you can call to Odyssey, and it will return the metrics which you're interested in. Maybe it's a long-term perspective. Currently, you can connect to the console and you can perform the command show stats. It's not the same, but you need to connect to console. Maybe there is a simpler solution. Exporter to where? The question is not audible. Okay, so we have another process which comes to Odyssey by Postgres protocol. Then they ask each other how they're doing, and they're listening at the same time to some port and can respond via HTTP. This is an interesting solution because there will be no dependence. We have a problem with Postgres like this, and we would like to have less dependence, to be less dependent. We actually can write it not using C, but something easier. Maybe Go. Okay, without voting this time. Without holy wars. Okay, thanks for your ideas. Anything else? Thank you for your presentation. I would like to ask the requirements for the compilator and the license. The license, I'm not a lawyer, to be honest. I don't know. It's open source. You can take the initial code. If you sell it to someone, I will be happy for you. It's better to ask GitHub about the license. And what kind of compiler we need? GCC? C standard? C99 standard. Thank you. You're welcome. Can you share any experience? How many connections are currently maintained? Typical errors? We limit by 20,000 client connections, and if 10,000 connections come at once, it creates overload. So some connections will go to a database, but CPU is not enough to actually process the queries for a long time, for example, for several seconds or longer if something goes wrong. Or if there is more than 500 megabytes of memory, then it means that also something is wrong with the program. It's too much. What? It says that it's not available. We put the databases in Porta containers, and we give them half of the available central CPUs, 10,000 connections. It works even on one CPU. But the question is how fast they will handshake each other. TLS handshake means 100 milliseconds on average. If 100 milliseconds is the high evaluation for one connection, then it can be 10 connections per second, which is not much. If you have 10 CPU cores, then some people will be able to perform their requests in 1 second. But 100 millisecond is pessimistic evaluation. Sometimes they can be faster, 10 milliseconds, for example. But TLS handshake is from 1 to tens of milliseconds for the CPU. Thank you for your presentation. The question, Odyssey Conf contains max client. It's used for what? It's a limitation of the overall number of client connections, or it's connections per worker, or there is possibility to limit the number of connections for each client. Let's say we have user number 1 in the database. I can allow 50 connections, and user 2, which I allow 100 connections to the Odyssey. Is it possible? Yes, it is possible. Let's start from far. Max clients is the configuration. When we process the client connection before we create a TLS handshake, we don't know who came to us, and the user will tell its login and password later when it will be encrypted. And connection is a resource which we would not like to waste if we are under overload. So max clients is the overall limitation for the whole number of connections. We don't know who is there. If we put 20,000, it means 20,000 incoming connections. And if user 1 came, in this case, we will tell goodbye, and we will not even start the TLS handshake. The user configuration is available. It's called, I forgot the name. I will find it. Pool size, if you set it 10 or 1, it will mean that after user connected with the second connection, the first one will be under transaction, and the second will tell us update something. It will wait for pool TTL seconds or milliseconds. I deleted the comments. So it will wait for pool TTL time, and if it will not finish waiting for the end of transaction from the first server connection, then it will be given error 5300, too many clients for this pool, please come back later. So in the end, this is configuration for server or for each client. Pool size can be determined. Database, and inside there is user. So for each user, you can determine pool size. You can do the same on the Postgres side, but it will give you the same response. Too many clients, and Odyssey will do the same. This is similar behavior, but it includes round trip to postmaster, which will respond right away. So it's unnecessary overheads, and this is why we install pool size. Okay, last question, and then we will have to finish. Hello, Andrey. I'm looking at authorization. In Bouncer, we have a separate file for user and hash. And here in configuration, you need to write the passwords. Yes, correct. So they are not put separately for convenience of administration. You can include configurations into configurations, and then you can read another configuration, and it will be the same, will have the same structure. Okay, clear. Understood. So you can configure the storage and listen in the same, and to actually configs should be improved. Recently a guy came to GitHub and he said, let's put some configuration in one user, and 3 more will be inherited. I think it's possible. It's not rocket science. It's just some programming, and it will work. We can also improve inclusion of other configs to take the sensitive information into a secure location, for example, on flash drive, which can be removed, and the guy can run away with this drive. It's just my fantasy. Thank you very much, and let's talk further outside of this audience.